Optics.
Here's here's 8.3.
Physics of solids. Movement.
What?
Nicolas.
Oh, I need to turn this one in. Oh, it's 5.2. What the hell? Where's 8.2?
Yep. Mechanics of solids. All right. So now that a few more people came in, anybody still need a practice test?
Is that just 8.1?
No.
Yeah.
Okay.
So what the hell?
All right. So any questions from homework? If you don't have a question about types of errors, I'm a little worried about your ability to keep up with homework. We will be going over types of errors later.
Question: when finding the standard deviation of a uniform solution, that's just b minus a over square root of 12, right?
B minus a squared over 12, a whole thing square rooted.
And he just hasn't graded it yet.
b minus a over square root of 12 is the same thing.
Oh yeah. Yeah. As long as b, B is understood to be bigger than a, it's fine. Yeah. And again, I'm not going to test you on that. It's just interesting to know it exists. Anything from homework besides the types of errors? I figure that might be a few questions. Anything else from homework stuff? Yes?
117 is on this one.
Oh, yeah. Yeah. So either, if it's z-score, you use a normal distribution, right? And use a z-score if you know the population standard deviation, right? If it's t-score, in order to use a t-distribution, the problem's got to be normal to begin with. But the answer to that question would be the t-distribution. If you have to use a t-score, that would be really section 8.2. That's where they introduced t-scores.
Do we have to write t-distribution, or can we write t-score?
Either way.
Okay.
I know what you mean.
Yeah.
Yes. Which one? Sorry? 62, okay. Ache. Oh, okay. This is the section where you just had to write in symbols the null and alternate hypotheses. H says Europeans have a mean paid vacation each year of 6 weeks. That's the claim. Are there any directional words in that statement? Directional words are less than, increased, has gone up, has gone down, decreased. There's no directional words, right? It's a pure statement of they have a paid vacation of 6 weeks. Mean paid vacation. So how do I write that in symbols? Mu equals 6. Exactly. So normally, not always, but when you're having trouble figuring out is it greater or less, it's probably equals or not equals to, because those words are easy to, there's not even any real words that kind of give you an idea, but there's no directional words. It's just a statement of, this is a fact, it is this. Oh, so that's mu equals that. So then the opposite would be?
Not equal.
Not equal to. So how many tail tests would that be? 2 tail tests, I like it. And that's extra stuff, right? Does that make sense? Normally when you're having trouble figuring out how to write it, it's because it's an equal to. And there's no giveaway words when it's an equal to. There's no less than, greater than, no at least, no at most. Yeah. Does that make sense? I mean, that's English language problem, and then math trying to take care of that. I'm a math apologist. I love that. Anything else from homework? Nothing? Okay. Makes me worried, but normally I'm an optimistic fool. Yes?
9.5, question 74. I was having trouble finding the word that one.
Having trouble finding the z-score?
Yeah.
Why? Let's see. I mean, how many tail tests is it?
1 tail.
1 tail. And alpha is 0.05.
Right.
So you look at 1 tail, 0.05, all the way down to the bottom of the t-score chart.
That's it.
There's a z-score, yeah. Is that the one you, critical region z-score or your z-star?
Z star I missed.
Z-star.
Yeah, I got it.
There is z-star. So z-star,
Yeah, this
oh, by the way,
confuses me.
this is the stuff about the quiz. The mean was almost 77. Standard deviation pretty big because of this,
Damn.
right? All right, 12, 17, 8, 5, 11, shit. Oh well. Normally this means you didn't do the homework beforehand, so that explains that. If that's true, if you're here, but it's because you didn't do the homework, this is the best kind of F to get. Because then you just do the homework and you won't make the same mistakes again. Is that simple? All right. So I don't, if you could identify everything you need, and for a z-star for a mean, well, that's not too bad. That'll be like t-star. I need x bar. Where does the mu come from for hypothesis tests?
That's your claim.
From the claim. And I need to know sigma, and I need to know n, so I can figure out the new standard deviation, right? If I can find all these things, I've got what I need for the z-star formula. Is that cool? So I don't know the specific problem that was had, because they give you all that stuff.
Yeah. Look at that. Right.
Okay. Anything else from homework stuff?
Are we going over
Maybe. We'll see what happens today.
No, it's just going to be on the test.
Yeah, you know me. I just stick weird stuff on the test. Nothing else. Okay. All right. Yes.
9.2, the type 1 and type 2 there.
Ah, okay.
You're gonna vote,
Yeah.
right?
Yep. Okay, let's do that. Let's talk about errors. So, the weird thing with statistics, the fact that it's the most honest math, that means there could be errors. That doesn't mean you made a mistake or anybody made a mistake. It's just built in. It's just life. I don't know for sure. But at least with stats, we get a feel for where it most likely is or something like that. That's what stats is really good for. So the types of errors. Let's first figure out, why are there two of them? Well, what's the conclusion that you can reach? How many conclusions can you reach with a hypothesis test?
2.
2. That's it. I know there are 4 statements you can write, but 2 of them, there's pairs that go together. Are you very with me? So what's one thing I could do? If I get into the rejection region, let's say, what would I do then? What would I do? If my z star,
Reject the whole.
I would reject the null. I love it. Okay. And the p-value gives me an idea about how possible it is that I'm wrong. It's the rough thing that the p-value gives me. So, built in right there, and we said this before, there's a chance that I'm wrong. So that's why it's related, that's why we call it an error then. So if I reject, so one outcome that could happen is I could reject the null, right? And when would that be a mistake?
When the hoe is true.
Yeah. When the null hypothesis is actually true. So if I reject what the null says, because I got so far away from the middle, it looks like it's good evidence that it isn't there, when in reality it actually is, and I just happened to get a sample that was really far away. That's not impossible. It's highly unlikely. So if I do reject the null, and it turns out the null was true, then I've made a type 1 error. Reject a true null. And they give us a nice physical example here in a minute. So what's the other possibility? This is type 1 error.
Support the hoe.
Other outcome, never support the hoe. You
support
never
the-
support it. A sample is never evidence that the null is true. It's either evidence that it's wrong or it's not enough evidence that it's wrong.
That one.
So I either reject it or I fail to reject it. So I can either reject the null or I can fail to reject the null. When is this going to be a mistake? When is it going to be an error? If I fail to reject what the null says, but the null is actually false. If I can't say he's wrong, but he's actually wrong, that's an error. That's a mistake. It's not a mistake you made in calculations. It's not a mistake you made in applying a formula. It's just built in. Probability statistics is all about there's a chance we're wrong. And that's why you should love statistics the most, because it's the most honest math. It's not x equals 7. It's 7, give or take. Which hopefully you understand after we've talked about everything we have, why that makes sense. So type 2 error would be fail to reject a false null. Sort of sounds like religious stuff when we're talking about hoes, but I won't. Fail to reject a false hoe. Okay. So let's do a real physical example. I'd like to give you one that's an example that's not mathematical, because hypotheses don't have to be mathematical in nature. So somewhere that we have to make go in with a certain assumption is if I was a medic on a battlefield, and what am I doing? I'm running around, there's people laying on the ground. What am I doing? What am I doing when I get to somebody laying on the ground? Say again? Well, I got to first figure out if they are alive or dead, right? And if they're only mostly dead, I can make a little ball, stick it in there. Mostly dead. Take a miracle. Thank you. That's all I need is one more, or even no less, because it's for me. So if I'm a medic on the battlefield, now we could have a little discussion about this, but what do you think my null hypothesis should be? What am I trying to find evidence for when I get to the person? I'm trying to find evidence of life. So my null, it kind of sounds weird. My null is that they're dead. And then I'm looking for evidence of life, right? So if I'm a medic on a battlefield, my null hypothesis is a person is dead. And then my alternate is person is alive. I like that. Or not dead. And you can have like zombies on a battlefield or whatever other kind of undead things. Is that pretty cool so far? I mean, I want you, one reason why I like doing this is to show you that it doesn't have to actually all be mathematical. It could be sentences. So what would a type 1 error be in this case? The person is actually, what? So I reject a true null. Person's actually dead, but I think they're alive. And in that situation, it's a lot easier than you think to think that. I mean, I could have taken the pulse wrong and felt my own pulse. I could have thought they breathed when it was actually just a weird little gust of wind. You understand what I'm saying? I can't even imagine what it's like out there. Bombs fucking all over, and you're trying to see, is this guy alive or dead? And you can make a mistake real easy. So the type 1 error would be, they're actually dead. It's a true null, but I reject that. I think they're alive. And why would that be bad?
You spend time working on that?
There you go. I waste time.
And you're getting shot at.
Yeah, exactly. There's more time out there for me to get a chance to be shot. And then, the backup medic's got to come out. He gets shot, and you're like, how many of these do we have? Sorry. It's a little morbid, so I'm trying to... Is somebody cool with that? You guys see that? Whatever the null is, you say, in actuality, blah, but we think the opposite. Okay, that's that simple. It's that simple. That's it. So type 2 error would be what?
You think they're
alive, but I
alive?
think they're dead.
They are alive, but we think they're dead. And why is that bad, obviously? If I think they're dead, I'm going to move on. And they're like, right? Yes? Maybe? Again, sorry, it's a little morbid, but oh well. They are alive, but we think they're dead. Now, this one is a little bit hard to tell which error is more, is worse. Right? You could argue both ways, to be honest, and in your head you could feel one way and then the second later you feel the other way. In reality, normally you can kind of get a feel for which error is worse, and then you can control alpha. All right, let me make sure. Everybody cool with just this by itself, the idea of the two types of error? It's not that big of a deal. I've got a problem like that on the practice test. I'll ask one problem on the actual test about the types of error. And I don't care if you really remember which one's type 1, type 2. The way I remember is the smaller statement is type 1. Reject a true. Fail to reject a false. Okay, that must be type 2. That's longer. That's the way I keep it in my head. Okay? But honestly, I don't care if it doesn't really matter. You said type 1 is type 2. It doesn't matter. As long as you can write what the mistakes would be. Okay, I like it. Now, the type 1 error, the probability of making a type 1 error is alpha. So if a type 1 error was worse, I would make alpha smaller. Does everybody understand? But making alpha smaller makes the probability of this one bigger. So it all depends on which one's kind of worse. That's what I kept saying about being in a nuclear reactor, and it would be worse. So you want to make alpha, it would be worse to make the mistake to not get off your ass to do something. So you want to make it easier to find evidence that you should get off your ass. So you want to make this one bigger and this one smaller, right? So you make alpha bigger so you actually get off your ass quicker. All right, anyway, so it's related to that. You guys understand? So there are these kind of errors built in. You can control the probability of making the errors, and that's why people's p-values might be different, depending on what they consider to be worse error to make. Okay, maybe. Okay. Oh, where was I going to go for that? I think that's everything I want to say about that. Yes. Yeah. All right, we're not going to get to the details here because it's not a simple relationship between these two, but just so you know this exists, there is something called beta, which is the probability of this one. These don't add to be 1. As this one goes down, this one definitely goes up, but there's not a direct, it doesn't go up by as much, the same amount. So this one's not terribly easy to get. It's a little bit weird, the work you got to do to actually get this. This one I can control directly. And it's true, if I make this one decrease, this one will increase, just not by the same amount. It's not like a perfect relationship. It's a little bit wobbly. So there's a probability you'll make a type 1 error. We can control that one directly. And then through that, we indirectly control the type 2 error's probability of happening. So really, again, it just depends on which one's worse. Now, if you take any more statistics, if anybody might even go a little further in stats, you'll learn this is called the power of the test, and there's a whole big thing about it. It's just a little bit more than we need to get into in stats 1. But it does exist. Is that cool? Okay, maybe. But I've been trying to get you ready for this for a long time, giving you these situations where the p-value might be treated differently by different people. Like the insurance company is going to be like, if you're trying to prove to them that you should have less insurance, they're going to make alpha really tiny, compared to what's worse or better for them. So that's why they make that happen. Okay, so that's enough of that. There's a whole section in there about type 1, type 2 errors. Hopefully that makes sense. Any other questions about types of errors? Okay. So when I ask you what types of errors, type 1, type 2, don't tell me, well, I could have put it in my calculator wrong. No. Not what mistakes could you have made. What errors built into the process could have happened. Yeah. Okay. We have, let's do this. Before we get into the new stuff, and there is some new stuff we haven't done yet, I want you guys to do a couple more straight up mean hypothesis tests. Not the opposite of nice, but just about the mean. And then we got to get into how do we handle hypothesis tests about percentages. So that's going to be the new stuff.
Is that chapter 10?
No, chapter 10 is what do you do when you have 2 samples instead of just 1 sample.
Joy.
Which in reality is more true to life. What are we doing right now? There's a claim about some known number. I know it's supposed to be 10, and somebody like, I think it's less. And then they go takes a sample, right? You with me? And then where the shit did the other guy get the 10? 10, it's in my gut, so it's got to be true. So in reality, chapter 10 is more true to life. We have two groups that we think might be different, and we have no idea what the real thing is, but I just want to see a mean for this side of the class and a mean for that side of the class, and I think that the means are equal. And then I could do a test. So that would mean I have an X bar 1 and an X bar 2. That's chapter 10. Let's hold off on that for right now. So here's one. This is just like the other handout we did together yesterday. Just 2 different problems.
Yeah, yesterday, Sunday.
Go ahead and group up if you want. If you don't like other people, you don't have to. You're like, the world would be great. No more other people. Just stay by yourself. You need to borrow a calculator, they're up here.
Only a little bit over, right? Why are we doing 12 before 11? Yeah, I'm almost on all of it except for now. I didn't do it on all of it.